So have you heard about NASA's James Webb Space Telescope? It's been up there for a while and, well, it put $10 billion through it. Is it making some good pictures? Yeah, that's one of them. That's pretty darn good. You want to learn some more about these great, amazing pictures of outer space? Stay up all night with me. So the James Webb Space Telescope, this thing has been in the works for a long time. NASA's been working on it, engineers have been working on it. It was over budget, overdue. And man, I gotta be honest, when it was going up there, I was nervous as all can be because they put so much time and so much effort into this. I was like, this thing better work, because if it doesn't work, we're not going to get another new telescope. I mean, that's the thing. You have this shiny telescope. If it doesn't work, we're not going to get a new one. Parents are not going to buy it. So this is what it looked like when it was in the factory getting all ready to go. And this thing is huge. I mean, all these panels with this kind of gold coating on it. This is way bigger than the Hubble telescope. And this is going to be basically like 10 to maybe even 100 times better than any other space-based telescope we've had before. So it launched from South America in this massive European Space Agency rocket. So they were the only ones that had a rocket big enough. And they had to fold everything up inside of it. So it kind of looked like this when it was all folded up. This is a nice little artist rendering of what this looked like. And so you got this giant telescope folded up into this small compartment. So you got to launch it into space. You got to unfold it. Then you got to position it, then you have to communicate with the Earth. And where they positioned this thing was not just like right above the Earth where you could go fix it. They put it 1 million miles away in a place called Lagrange Point 2. So it's in this nice little wake out there as it's circling around the sun with us. And so Lagrange Point 2, yeah, 1 million miles away from us, which also means we are not able to go out and service it. So if there's any things that go wrong, like something's wrong with the panels, something's wrong with the communication, we can't fix it. It's on its own, 1 million miles from Earth. So as you can tell, yeah, that's good reason to be nervous, because I don't know if people remember the Hubble telescope when they first put it up in 1990. It didn't work. They had to go up and fix it. And so we were hoping, this is what we're looking for, is that it would give us these insights into these areas of space that we couldn't see very clearly before. So on the left is a picture from the Hubble telescope that shows this thing called the Eagle Nebula in visual light. So this is what the eye would see. And on the right is an infrared view. So the James Webb telescope will be able to see an infrared, not visual light like Hubble did. The plus is, at least supposedly, is that you can see through all that cloudy structure. So the picture on the left is very cloudy. Picture on the right, you're seeing through those clouds and seeing stars and other structures. So, did it work? All right, so the telescope went up there, 1 million miles from Earth, took some pictures. This is the first official picture that came back, and yeah, it was pretty sweet. This is a picture of galaxies upon galaxies upon galaxies. When we're looking at this, every little spot of light is a galaxy like the Milky Way with billions and billions of stars in it. All right, except for the ones that have like the little star patterns. Those are stars, but the other ones are all galaxies. And so we're looking at thousands of galaxies in one picture. And what was great about this was the resolution. We could zoom in on this. And so we can zoom in onto individual galaxies. And some of these are galaxies that have never been seen before. Now, if you go back to that picture here again, do you see some kind of like warpy stuff, some warpage? You can see some of the galaxies are kind of like rounded. And this is something that has been theorized for a long time and only captured rarely. But what we're seeing is called gravitational lensing, is there's a big mass in front of it that bends space and time. And so galaxies that are behind a big mass will come out in this weird like funhouse shape. I mean, like, look at this galaxy. It's like all messed up. That's not really what it looks like. It's coming around space and time. And so a picture like this, oh man, this one blew me away. For a first one, not bad at all. Well, what do they follow it up with? Just the Southern Ring Nebula. I mean, this is a sun-like star. This is a star that's maybe about used to be as big as our sun. And this is what happens at the end of its lifetime. You get this thing called a planetary nebula. And so we have the star that's in the center that can't hold itself together and sheds all these gases in these great rings. And so the Webb telescope has two ways, well, actually there's more than two, but here's two ways that it shows the light coming through. And in this picture, you can actually see something that nobody had ever seen before. The resolution was so good that just actually some guy that saw this picture on the internet said, hey, what's that thing up in the upper left corner? And the astronomer's like, what thing in the upper left corner? He's like, that thing in the upper left corner. And they're like, oh, we've never seen it before. It turns out to be a galaxy. And it was discovered by just somebody like watching it on Reddit or something like that. This is a galaxy we've never seen before. Pretty cool. Then we've got this group of 5 galaxies called Stephan's Quintet. These are 5 galaxies that are interacting with each other. So think of like billions of stars and billions of stars and billions of stars, and they're passing each other and warping all of their stars around. There's kind of a cool app you can get called Galaxy Collider, where you can like simulate this kind of thing. You can do 2 galaxies, 3 galaxies, 4 galaxies, 5 galaxies. You can run them into each other. Has no real scientific merit, but it's a lot of fun. Try Galaxy Collider, it's pretty good. I like this picture is one of my favorites called the Carina Nebula. This is a star forming region in a southern constellation. So we can't see that too well from the United States, but in the tropics and farther south, they're able to see this. But with this kind of resolution, we have never seen a nebula with this kind of resolution. So this is places where stars are being formed from these big, huge clouds of gas and dust. Oh yeah, this really close-up view of it. As we can see, oh man, there's star forming regions right here behind me. We've got, they call these the cliffs. This is places where clouds of gas and dust are coming together. Gravity is bringing them together into a huge nebula. This is kind of like the Orion Nebula that we could see in the northern hemisphere. And then we got our planet pictures. When this picture came in, this was the first planet picture that they sent. This is Jupiter. Now, if you notice, the color is all weird. It's not really that neon purple color, but the James Webb Telescope doesn't see in visual light, it sees in infrared. So they have to assign colors to the things that they're getting. In this case, they chose purple. I don't know why they chose purple, but that's what they did for this one. So you can see the stripes of Jupiter. You can see that great red spot that's right there, now shown as white. And the resolution is so good that they can even pick up the rings of Jupiter, which are really hard to see from Earth-based telescopes. You see a little ring there that's going around there. This was one of the amazing things that we're able to capture. So this is just the beginning. I'm waiting for Saturn. We need a Saturn picture. Come on, guys, get with it. Let's get a Saturn picture. All right, so when people find out you're an astronomer, they instantly have astronomy questions. And so that's why I do this segment here called Hey Dean, because yeah, once everybody knows I'm an astronomer, they start off with, hey Dean, and then they talk about what they've heard. And so some people that have been following along with the Webb telescope, are amazed by pictures like this, the Cartwheel Galaxy and some other things. But the question I get from Jenny from Norwood asks, didn't something happen to the Webb telescope? Didn't something like hit it and damage it? And yep, absolutely positively. The Webb telescope was damaged very early on in its flight. As it got out to its million miles from Earth, a micrometeoroid struck one of the panels and damaged it really badly. So you see all these segmented mirrors. All these mirrors act as one. They collect the light of all that and funnel it to the sensors. But one of the panels got struck by a micrometeorite, and it's that one labeled C3, and is either not working at all or is only partially working. So the damage was pretty extensive, but they kind of foresaw this. So astronomers were ready for this kind of thing because you got all those other panels that are still working great. Problem is, what if more panels get hit? And it could be only a matter of time before that happens. Being out in deep space could be dangerous for this telescope. So that's why we got to use it as much as possible while we got it. So final thing I got for you tonight is James Webb Telescope compared to the Hubble telescope. this is what the two of them look like together, side by side. Yeah, it's a big difference. And the Hubble telescope, I think, is going to go down as one of the best scientific instruments humans have ever made. But James Webb is going to be about 100 times better than that. So the thing is, will it last? Fingers are crossed. But I want to give you kind of an example of the difference between the two telescopes. So here's a picture taken by the James Webb telescope of this galaxy with not a very cool name, NGC 7496. I know they need to have a better name for it. I don't know. Galaxy Regus sounds pretty good, but let's just go with that for now. This is the comparison of the pictures from James Webb on the left to Hubble on the right. Now, when you look at these, you're like, I don't know. At first glance, maybe the Hubble telescope picture looks prettier, doesn't it? I mean, you got these kind of cloudy structures. It looks more artsy. But what's happening is you're able to penetrate through that cloudy stuff. So astronomers don't like stuff in our way. We don't like clouds. We don't like dust. We like to get right to the heart of the matter. And so that's what we're seeing with the picture on the left with Webb, is we're seeing all these structures and all these formations like we never did before. Then we got this galaxy here called the Phantom Galaxy, which, by the way, I've been doing this like for 20 some years. I've never once heard anybody refer to this galaxy as the Phantom Galaxy. I think NASA's just making some stuff up, but anyway, I'll go with it also. Phantom Galaxy. Yeah, I mean, it's kind of spooky looking. We're looking right down into the center of a galaxy, and we want to compare this to Hubble. So this one, you can really tell the big difference is you're zooming through all that cloudy stuff. So again, the Hubble picture on the bottom, real pretty, real awesome, real cool. But the one on the top, we can actually get some real info from it. So that's it for this episode. I hope you enjoyed, learned a little more about the James Webb Space Telescope. I'm going to be watching it real carefully because every week or so they come out with some really cool pictures. But follow along with me here and I'll keep you up to date on what's up in the sky. And so as we say around here, why not stay up all night with me?